Good morning to all of you. So, today's class we are going to study the problems in impulse invariant method. Now, let us solve one problem based on impulse invariant method. So, you know that procedure before going to the problem, we know that the procedure for impulse invariant method is first of all we have an analog filter transfer function. The main aim of this impulse invariant method is we need to convert the analog filter transfer function into a digital filter transfer function. That means h of s into h of z. So while you're converting the h of z into h of z, there are so many intermediate steps involved. So that we are going to discuss and solve it in the problem. So the first step is if you are given a transfer function h of s transfer function, we need to apply inverse Laplace transform as it is given in the first step to obtain h of t. Then after that we have to apply the sampling process. That means we'll be substituting t equal to n into capital T. So we have after applying the sampling process t equal to n into capital T. So we have h of n equal to h of nt. Then you have to apply z transform for that h of n to apply the transfer function, digital transfer function h of z. So these are the steps involved in it. So first let us solve a problem based on h of s equal to 1 by s plus 1 s plus 2. So here in this problem we cannot directly apply inverse Laplace transform. So first of all, we have to apply the partial fraction method and then find out the bring it in the form so that we can apply the inverse Laplace transform. Now in this given problem, when you apply the partial fraction, it is a by s plus 1 plus b divided by s plus 2. Then you can take an LCM of it and simplify. So we will be getting this kind of equation. In that first substitute s equal to minus 2, find the value b, you will be getting at minus b equal to minus 1. And when you substitute s equal to minus 1, you will be getting the value for the a which is equal to 1. So now we have a equal to 1, b equal to minus 1. We will be substituting in these equations. So h of s equal to 1 by s plus 1 minus 1 by s plus 2. Now it is easy for us to apply the inverse Laplace transform. So when you apply the inverse Laplace transform for this particular problem, you will be having h of t equal to 1 by s plus 1, it is e power minus t u of t, minus 1 by s plus 2, it is e power minus 2t u of t. Next step is we have to apply the sampling process. That means wherever you have t, you have to replace with n into capital T. Now h of n equal to h of nt equal to e power minus n into capital T u of t minus e power minus 2n into capital T u of t. Then the next thing is we have to apply the Z transform. So u of t is nothing but a unit step signal. It is 1 for n greater than 0, 0 for n less than 0. So if you apply the Z transform, according to the Z transform, the formula is minus, summation n equal to minus infinity to infinity x of n z power minus n. So x of n is nothing but this term. So here you have u of t. Since you have u of t, it is already defined. It is 1 for n greater than 0, 0 for n less than 0. So in that case, the limit will change from minus infinity to infinity to 0 to infinity because of this unit step function. So the limit is summation n equal to 0 to infinity e power minus nt z power minus n minus of summation n equal to 0 to infinity e power minus 2 nt z power minus n. Now in this we will be taking the common term outside. So n will be taking it outside. So e power minus t z power minus 1 whole power n minus here also we will be taking the n outside. It is e power minus 2t z power minus 1 the whole power n. Now this equation it is in the form of summation n equal to 0 to infinity x power n, which is equivalent to 1 by 1 minus x. Like that when you consider this term as x, we can write the transfer function as 1 by 1 minus e power minus 3 z inverse minus for the second term it is 1 by 1 minus e power minus 2t z inverse. Then you take the LCM of it and simplify it further. So you will be getting the expression, final expression as h of t equal to e power minus t minus e power minus 2t z power minus 1 divided by 1 minus of e power minus t plus e power minus 2t z inverse plus e power minus 3t z power minus 2. Now when you see the transfer function, it is in the common form like this. like b naught b1 z power minus 1 plus b2 z power minus 2 plus etc. divided by a naught plus a1 z power minus 1 plus a2 z power minus 2 etc. Because this is the standard way of expressing the IIR filter transfer function. So our output also in this form. Okay, so this is the answer for the given problem. Now let us move on to the next problem. The next problem is h of s equal to s plus y divided by s plus 10 whole square plus 25. Now we'll see if you want to take the inverse Laplace transform. So this is in the form of s plus a divided by s plus a whole square plus b square. So the inverse Laplace transform, this s plus a divided by s plus a whole square plus b square is e power minus at cos bt. So here a is nothing but the 5, b is nothing but it again it is 5 square, it is 5. So according to this, when you directly apply, you will be getting this particular equation. Then we will be doing the sampling process, t equal to n into t. Then we will be expanding the cos b and t. You know that cos theta equal to e power I theta plus e power minus I theta divided by 2. Like that, when you expand for the cos term, you will be getting e power I b and t plus e power minus I b and t divided by 2. So now the equation is h of n equal to 1 by 2 of e power minus a n t. 1 by 2 will be taking outside e power minus a n t into e power I b n t plus e power minus a n t into e power minus I b n t, like this. So now we take the n and t as common outside. So we will be having the expression like this. So after that, when you apply the z transform for it, it is 1 by 2 of 1 by 1 minus e power minus a minus of a minus ib of t is that inverse divided by 1 plus 1 minus e power minus of a plus ib of t z inverse. Now when you take the LCM of it and then simplify it further, you will be having this expression. Now in this expression, you substitute the value for a equal to 5, b equal to 5, because according to this, it is a equal to 5, b is 5 squared 5. So when you substitute those values a and b value here, you will be getting the expression, simplified expression as the answer is 1 minus z inverse e power minus 10t cos phi t divided by 1 minus 2 into z inverse e power minus 10t cos phi t plus z power minus 2 e power minus 20t. So this is the value, that is final output value for this given problem. Okay, so thank you.